Hi, I'm Joshua Omadaon,
And I'm Gary Young.
and today we're going to be talking about privacy for infrastructure, addressing privacy at the root, also known as how not to externalize privacy costs onto infrastructure clients. So, I've been at Google for a while as a software engineer, and I'm responsible for leading privacy review for infrastructure there.
And I've also been working at Google for a while, focusing on infrastructure privacy topics.
So we're going to do a quick overview. We're generally going to walk through some definitions, make sure we're all using the same terms, talk about what the purpose of infrastructure privacy review is, how we look at doing that sort of review, and what we think that such review may look like in the future. So, what is infrastructure exactly? We characterize it as systems that provide other systems or products with capabilities. Another way of looking at it is what you notice when it breaks, or to quote last week tonight, infrastructure, if anything exciting happens, we've done something wrong. Types of infrastructure include storage, networking, data processing, server frameworks, libraries, system integrations, and so forth. While each type of infrastructure has a somewhat different set of privacy concerns, there are definitely common threads, which we'll be coming back to. We also use the concept of a data agnostic system, which is intentionally unaware of the kinds of data that it handles. Reasons why one might create such a system include generality, so that it can work with any kind of data, simplicity, so as to avoid having client-specific business logic in your infrastructure, and in some cases, avoiding responsibility. We just handle data. It's the client's job to do it right. This is strongly related to the concept of a data processor versus data controller from the GDPR language. Note that if the system is data agnostic, then its owners are responsible for making sure that their clients know how to use the system in a privacy appropriate fashion, since they're not taking care of those concerns for their clients. So, why do we review infrastructure for privacy? We review the products, so is that not sufficient? This is arguably analogous to asking of a security person, can't we just review the applications since we've, and not the operating system, since we've already got the app sorted? In addition, solving privacy at the infrastructure level benefits all of the users of all of its clients. We already expect infrastructure to be transparent about what engineering problems it solves and how well it solves them. And privacy is another client requirement. Also, if your infrastructure scales very well along traditional engineering dimensions, but not along the privacy dimension, then you have a very well-scaled privacy problem. So how do we look at this? So product privacy review concerns include things like what user or personal data does the product handle, including collection, reading, writing, and processing, whose data, what does the product use the data for, are all the data required, or can some of the collection and handling be optional? Where are the data stored? Who has access? How long is it retained? And so forth. Infrastructure privacy concerns include the usual that we mentioned above for products, plus how does the infrastructure help its clients to meet their data handling needs? This is key This is a different level of abstraction than product privacy reviews. So some of the privacy concerns that we look at for infrastructure systems include, for client-provided data, what kinds of data are involved? Is the system data agnostic? For system-generated data, such as usage logs and error messages, then some of the same concerns apply to data that might be coming in elsewhere, especially if personal data might be showing up in those logs and messages and so forth. For the clients, infrastructure is best off if it knows who its current and intended clients are, has some way of recognizing this. And to have a good answer to the question of how many clients can it handle. And by that, I don't mean system load in terms of, CPU usage or, queries per second that it can manage, but how much work is required in order to get the system into a good privacy state, what you might call configuration load. You also need to consider the use cases that this infrastructure is meant for. Now, what categories of data are in scope? Does that include personal data? What are the current uses? What are the planned uses? What are the possible uses? And could unplanned use cases present privacy issues? Examples of unplanned use cases are arbitrary strings. Anytime you've got a system that can store arbitrary strings, you can be putting basically anything in there. Data agnostic services, as we discussed earlier, present some challenges. A particularly fun example is if you've got a system that you are building for social sharing, and you put this on top of an eventually consistent data store, then you may have interesting things like you block someone, and then you post about that person, and the block takes effect after the post does. Some other privacy concerns for infrastructure: access control. How is access to the system itself controlled? How do clients control access to their data? This leads to cross-client data isolation issues, which can crop up in particular when you have a piece of infrastructure that's originally designed for a single client, and it is starting to be used for many clients. Considerations that just don't crop up when you have exactly one client. All of a sudden, things get complicated when you start adding new ones on. Is access to the data logged? Do those logs contain information about who accessed it, what they accessed, when, how they accessed it, and why? Did they have any sort of justification for this? And in general, something that we need to be aware of is that people who manage a system should not have unfettered access to it. This is arguably somewhat of a change from where the industry was, say 15 years ago, when it was natural to assume that anyone that was going to be using running a system needed to be able to look at any of its data at all times. Now that we have so much personal data floating around, that's a lot more problematic. Retention and deletion. How can clients delete data? Can they even delete data? Can they do it in bulk? Can they do individual records? Can they do pieces of individual records? And how long does each step of deletion take? If you have layers of infrastructure, that can add unexpected latency and complexity. What about backups? And finally, what infrastructure does your system depend on, and is it properly configured?
So taking all those factors that we just discussed and putting them all together, how much configuration is really needed by clients to achieve a good privacy state? And this may vary by particular topics that you care about. It may be really great. It may require zero configuration, and it's not even possible for people to get in a bad state. It may be that you land in a good state or a safe state by default, but you can opt out of it, and that should ideally be visible to your privacy reviewer. It could be that you have to do significant per client configuration or code to actually get in a good state. The default, the work they have to do from the default could require coding. And if you're working with clients that are sales and marketing teams, they may not have engineers to work with to help fill those needs. Does it require extra privacy specialty to actually understand what settings you need to set here? Or it could be that getting into a good privacy stance is not even possible. So if the underlying system can't delete data, then storing data that you want to have a retention story around may not be possible. So here, the documentation of what's needed is really critical. You need to know where all the sharp edges, and people who are using the system actually need to know what those are so they can take appropriate actions. And it may also be that in some cases there's a difference between the historical clients and the new clients. So there's additional factors you might want to consider as you improve a system. Next slide. So often in the industry, we end up making these decisions between building versus buying infrastructure. So if you build your own infrastructure, you can tailor it specifically to your requirements, including your privacy requirements, but it may require more time and investment. When you're buying infrastructure or software as a service, you get stuff relatively off the shelf. It's usually pretty quick to deliver, has relatively predictable costs, but you have less visibility or control into the privacy state of things in many cases. In fact, you may end up making use of a industry-leading provider that doesn't actually consider privacy to be an important differentiator, and you may actually get a worse privacy state than you would otherwise expect. So it's important to understand the requirements of the data that you're using before you put it into the system, and so therefore it's important for the system to be clear about what types of data would be appropriate to use it for or not. Next slide. So here's some warning signs or things that commonly go awry when we're thinking about infrastructure privacy. So if you are only negotiating with an infrastructure team via their clients, then you're negotiating requirements through a game of telephone, and you're very likely losing fidelity of the things that you're trying to get out of the infrastructure. If you are using product-oriented methodologies to review infrastructure, then you're very likely missing some of these points that we just discussed around the difficulty that it takes to get into a good state. It's not just important here for it to be possible to get in a good state, especially if you're in a large company, you want to make it very likely or unavoidable to get in a good state to help manage the costs of your privacy function. Undocumented, if you're not documenting your infrastructure standards or expectations, then it's very hard to expect infrastructure providers to meet that standard. So it's important to document what you're doing with infrastructure together with what you're doing with products. If you assume that off-the-shelf infrastructure will satisfy your requirements, that may work for normal companies, but if you have bespoke requirements or due to injunctions against your company, or if you have been doing a lot of privacy innovation, it may not be reasonable to expect that off-the-shelf services will meet your company's specific needs. If the infrastructure team's goals are not aligned with the client's goals, then you can end up with unexpected outcomes. This can happen across company boundaries, but it also can happen across organizational boundaries in a large company. So this will happen frequently within a company when you use infrastructure provided or developed for one particular use case for a use case that it wasn't expected for. With great power comes great vulnerabilities. If you make infrastructure that's Turing complete, then it can be used for any and all things, and therefore it may well be used for any and all things. And making that safe becomes much more difficult. The final thing to be cognizant of is when you are making choices around infrastructure, sometimes it may be appropriate to externalize some costs onto a privacy team, especially when you have no reasonable alternatives for how you would design the infrastructure to avoid them. But the key is not to do that in a completely uncontrolled fashion. If you have no mechanism by which to push requirements back into the infrastructure team, then you end up with runaway costs in your privacy function. Next slide. So here are some things that we'd like to see in the future of the way that we go about infrastructure privacy review. We want to see a broader systemization of the different types of infrastructure and the different common solutions that we might bring to bear in those situations. So make sure that privacy engineers have a good toolkit of the principles and practices and solutions. We want to make sure we communicate infrastructure requirements to infrastructure engineers rather than product requirements. We want to make sure that we push privacy requirements as deep in the stack as reasonably possible, because this improves the efficiency and scaling of any solution or piece of work that you do to make things better. We think it's important for there to be infrastructure-oriented risk frameworks. So not just so having a common language for evaluation, but not just focusing on risks, but focusing on the cost and scaling issues that happens when you are trying to get large numbers of people to do particular workarounds that may not work in terms of funding models for a company. Another concept that we think is really useful to add in here is that in a engineering sense of the word contracts, APIs are a contract between clients and the infrastructure. So being able to articulate privacy expectations along an API definition is also a useful technique. Finally, when you've got a piece of infrastructure that can be used in a very general purpose fashion, it may not be reasonable for it to understand and introspect the data at a level where it can have high fidelity controls and automation. However, if you can put some metadata around the definition of table, then you may be able to still add back in some good automation in terms of the way that things are configured. So if it's set up to say that it's storing health and medical data, then turning off the encryption at rest flag may not be something you want to allow. So this concept of using annotations on the table definitions is actually a really good way to enable better scaling and automation for lower level systems. The annotations will also help improve your alerting, auditing, and metric story. Next slide. So thank you for listening to us. We appreciate your attention, and we look forward to your questions.